Okay, let's talk about declaring and comparing strings. A couple of important things to note, especially if you're stepping into some of the technical rounds. A lot of them have to do with string comparisons and declarations. So let's look at this. Just so you know, there's different strings we talk about. There's the literal string, which is just anything enclosed in double quotation marks. There's a string variable. That's when you create a named memory location that is an object of the string class. And then there's the class string, that's the blueprint, that's automatically imported in every program. As we'll discuss later, string builder and string buffer are also imported into every program and are useful operations for certain algorithms. Now there are basically two ways of declaring a string object. This is important because you can declare a string object really quickly. It kind of acts like a primitive. You can say string a greeting is equal to new string by explicitly calling the class constructor, or you can eliminate the new and it still works because strings are set up to work that way. Realize the string itself is distinct from the variable used to refer to it because it is its own little memory box. The variable holds that reference. When you compare strings, know that each created string is a class object. So the variable name is a reference variable that references that location in memory rather than to the object's value, as we discussed with equals and double equal signs. When you assign a new value to a string, the address held by the string is altered, and it looks like this. We have that aGreeting function where aGreeting is assigned, and if we change aGreeting from hello to bonjour, the old address where hello was held is bulldozed effectively. A new address is assigned, and ultimately the garbage collector comes and collects this value. Realize the old value has been destroyed, a new value is being added because strings are immutable. And that, of course, brings us to this concept of immutability. Objects that cannot be changed, such as strings, are immutable. Using simple comparisons between strings often produces misleading results. Now, I know you're thinking I'm beating this dead horse too much because we've discussed this in a previous video, but this is very important because when you run into problems like this, you'll know you use two equal signs instead of the dot equals operator. Use the dot equals operator unless you're testing for aliases. That is, two particular memory variable names pointing to the same memory address. If you're checking for aliases, use two equal signs. If you're checking for just contents, use string dot equals. String dot equals evaluates the contents of two string objects to determine if they are equivalent contents. It returns true if the objects have identical content. So a capital letter, for example, will not return true if the case is different. And equals ignore case does ignore the case. This is useful when users are typing in prompts because users don't do normal things. They try to mess up the program. And by using equals ignore case, you can avoid those issues. Let's step into some code and check that out. So here's Carmen, again, that familiar program we've worked with before. Let me clear the screen, and I'm going to run this program just as we did before, but I want to show you guys what happens when I type in Carmen. Carmen does not equal Carmen. That is true. So let's make this equals ignore case. When I do that and I run the program again, I'm going to get true for Carmen. Oh, well, I need to actually compile the class, as you know. All right, so now Carmen does equal Carmen because we're using equals ignore case altogether. So that's a kind of important method. I should take this off as incorrectly to correctly. Also ignoring case of the user input. Cool. All right, so that works. And yeah, there is, of course, one more thing to look at, and that's the compare to method. Compare to method returns two strings, returns the difference between letters. So if the calling object's less than the argument, you get a negative number. If the calling object's more than the argument, you get a positive number. Let's also look at that in code with a similar program. So here is the same Carmen program. I made the name Amy instead though, and we are going to once again clear the screen, and I am going to call the compare strings method, compile it, and call it, I'll just do it this way, javac java.compare strings. Let me run this. I'm going to type in Bob. And Bob is -1 because A is 1 less than B. But let me type in another name. And that name's going to be Abby. 11. What happens? Well, what happened is this. Amy checks Abby. The A's are the same. 0. It goes to the second letter. And in the second letter, M is 11 spaces after B in the alphabet, so it returns a B. That's how the compare to method works. There are also empty and null strings in Java, and let me talk about the difference. An empty string simply means it's a memory address with no characters. It's like 2 quotation marks, nothing in between. A null string means it has not been instantiated. You can use the empty string in string methods. It is pointing to something. You cannot use null. It will give you a null reference exception error. So make sure you're aware of that. If you get this null error, you know you haven't instantiated your string. And we will stop the recording here.